Bismillahirrahmanirrahim. Assalamu alaikum. Westfire and Food Health presents Nano and Plasmonic Antenna and Structures. It is our final year project. Our supervisor is Dr. Sadiqullah and co-supervisor is Engineer Usman Ali. Group members are Muhammad Adnan Sultan, Walid Shadat Paran Khan, Sundar Sattar. Agenda: EM spectrum, how it works, role of EM, advantages and disadvantages. Agenda and types of antenna, plasmonic antenna, background and motivation, research in optical antenna and its applications. EM spectrum, we are analyzing EM spectrum. So if we see at the left side, we have gamma rays, X-rays, ultraviolet, visible light, and visible light, infrared, microwaves, and radio waves. If we see at the lower right side, we have longer wavelength, lower frequencies, and lower energy. So radio waves have high energy, and gamma radio waves have low energies. And at the leftmost side, we have shorter wavelength, higher frequency, and higher energy. Light is a composition of 7 color: red, green, blue, and these 7 other. So if you see, these seven color are itself is the combination of 3 main colors: red, green, and blue. What is light? Light is electromagnetic waves that radiate a specific wavelength. It has specific amplitude, and it moves in a specific direction, and it has E field and H field, and both E field and H field are at right angle and the angle between them is 90 degree. Photon is a packet of light. When it incident on specific material, sometimes some part of its energy is scattered, and some part of its energy is absorbed and transmitted. Combined properties of EM waves and light. As we see, waves have some properties as like transmission, reflection, refraction, diffraction, absorption, scattering. So these properties also exist for light. Plasmonic. The term plasmonic nano antenna. The plasmonic nano antenna is deal with light matter interaction. I mean to say that plasmonic, the term plasmonic deal with the light matter interaction, and since we are studying plasmonic nano antenna, so that's why we have written that the term plasmonic nano antenna is dealing with light matter interaction. Nano antenna is an antenna which have dimension of nanometer scale, and its work on terahertz bands. Optical or plasmonic nano antenna. Optical or plasmonic nano antenna are antenna that work on free electrons, and these free electron or several plasmons are present in the metal, and it can be excited through external field. And when optical antenna emit light, it's move from the free space, and there they produce a dipole moment. I mean to say that when these free electrons moves in the metal, it's produce a dipole moment, and due to this dipole moment of electron, it's generate electric field, and this electric field leading to the emission of free space radiation. space radiation. So electromagnetic waves which are generally radiating in the free space is due to the dipole moment of free electron. And another term which we are studying is localized surface plasmon. LSP is the plasmonic mode associated with the resonance of the free electron plasma in a small metallic structure due to an external dielectric field. Surface plasmon. Surface plasmon are actually the collective excitation of free electron on metal surface, or excitation of conduction electron metal which couples into electromagnetic radiation allow propagation of light. Combined properties of EM waves and light. uh, as we see, waves have some properties as like transmission, reflection, refraction, diffraction, absorption, scattering. So these properties also exist for light. uh, surface plasmon. One important condition for surface plasmon to exist is that the two materials should have different sign for real part of their dielectric material. For example, noble materials just like gold, silver has complex negative permittivity, and dielectric materials have positive permittivity. So these noble metals and dielectric materials are used for the design and excitations, and for surface plasmon to exist or using. And another term is localized surface plasmon. A localized surface plasmon (LSP) is the result of the confinement of a surface plasmon in a nanoparticles, or another word we can say it antennas of a size comparable to or smaller than the wavelength of light used to excite the plasmon. So we can say that the localized surface plasmons are due to the confinement of free electron confinement due to confinement of surface plasmon or free electron in the antennas, which has dimension dimension equal to half of the wavelength or in between them. Surface plasmon polariton. Surface plasmon polariton are actually electromagnetic waves that occur due to plasmon or electron and dielectric metal interference, and these surface plasmon propagate along the metal interface. So if we see this 2D picture, or I mean to say that if we see in this image, we have above dielectric, and below we have metal, and these E fields are representing the superplasmon, and it is generated at the interface of um, this dielectric and metal interface, and due to this surface plasmon, EM waves are generated. Existence of plasmon. A surface plasmon, as we saw in the earlier, as we saw in the previous slide, these are exist and at the dielectric metal interface. So we have two dielectrics. One has high dielectric permittivity, and in between we have high dielectric permittivity, and other dielectric is low dielectric, and metal is sandwiched between these two dielectric material. So surface plasmon exists at these two material interface. So surface plasmon exists at the interface between dielectric material and Surface plasmon. Surface plasmon are actually the collective excitation of free electron on metal surface, or excitation of conduction electron metal which couples into electromagnetic radiation allow propagation of light. Plasmonic nano antenna advantages and disadvantages. High bandwidth and disadvantage, difficult to fabricate. Another advantage is very small size, can be used for interchip communication. High speed electronic circuits. Disadvantages is like difficult to fabricate, metallic losses, copper are lossy at higher frequencies, and at terahertz frequencies itself. Um, for that purpose we are using superconductor, just like noble metal is like gold and silver, and these are useful in antennas designing at terahertz frequencies. And other disadvantages is it can be used only for indoor communication and small size wavelength, so high losses occur. Difference between RF and nano antenna. So at the right side we have nano antenna, and at the left side we have RF antenna. So the RF antenna size is comparatively large than nano antenna. Difference between optical or plasmonic antenna and RF antenna. For RF antenna, we are interested in far field region, and feeding device are required. Current cause waves. Maxwell's equation or flight size in millimeter or centimeter, and resonance frequency are used for designing, and frequency range, and for RF antenna designing we are using frequency ranging from kilohertz to gigahertz, and the skin depth of RF antenna is equal to 20 to 30 nanometer, and participate few electron participate. In case of plasmonic nano antenna, we are interested in near field direct light. Direct light excitations are required, and surface plasmon cause waves. Maxwell's equation are also applied. Surface size is in micrometer and nanometer. So I mean to say that the dimension of plasmonic nano antennas is definitely in nanometers. Resonance wavelength are used for designing, and numerical approach, and for analytic approaches. Um, its bandwidth are in frequencies. Its bandwidths are in terahertz, and we use designing in terahertz frequency region. Skin depth is greater than diameter of antenna, and for plasmonic antenna, complete electrons participate in its excitation. Maxwell's equations. D is representing electric flux density, E is representing electric field, phi or rho is representing charge density, B is magnetic flux density, H is magnetic field vector, and J is current density of electron. Divergence equations. Divergence is actually the dot product of vector and delta. So if we see the delta dot electric field density is equal to rho, and delta dot magnetic flux density is equal to, while the curve of the electric field is equal to changing in magnetic flux, and the curve of the electric field is equal to changing in electric flux with respect to time plus current density. For plasmonic antenna fabrications, we are using electron beam lithography method and solid state super ionic stamping, and the literature review that the super ionic stamping is better, and it is good. Challenge in fabrication. Fabrication is a big problem. And literature review says that we can literature review that 10 nanometer size can be fabricated with existing technologies. Aim of our project to understand the new technology of nano and plasmonic, how optical antenna works, design and simulation on nano scale with useful application to analyze the performance of antenna. Objectives: design and excitation of nano antenna in CST microwave studio, choosing the best geometry for nano antennas. I mean to say that we will choose the best shape and geometric shape for nano antennas, which giving us comparatively good result in case of in terms of gain directivity, high radiational efficiency, and beamwidth, etc. And we will calculate the gain and directivity of nano antenna, and analyzing the gap and behavior of gap in bow ties antennas and in other antenna itself, and we will calculate the Meyer near field, or far field, etc. For excitation technique, for plasmonic antenna to excite, we are using light, and there is no option of light in CST. So for that purpose, to excite a plasmonic nano antenna, we will use waveguide 4 and plane wave. Shape and the relation between shape and wavelength. So the relation between shape and the resonance wavelength is still actively studied, as there is a strong and partially unknown connection between the two has been founded, and we can see that the we have some basic shapes which have specific resonance wavelength, and when we bring the same shapes to close to each other, it start coupling in each other. So we can see here that we have different shapes of different sizes and different wavelengths. So we have studied these shapes in case of wavelength and other features. So the relation between shapes and the resonance wavelength is investigated experimentally and numerically, and the solid line are representing these solid line in the above images are representing the experimental results, and the dotted line are representing the numerical results for rods and other shape of antenna, and their immediate forms are given in these pictures. Agenda and types of antenna, plasmonic antenna, background and motivation, research in optical antenna and its application. Plasmonic application of plasmonics nano antenna and its advantages. Nano antenna may be used and integrated into high density application circuit, wider bandwidth compared with it's provide us wider bandwidth, large bandwidth as compared to the traditional antennas, because we are getting and the plasmonic nano antennas we are getting bandwidth in terahertz, and in the case of traditional antennas the wavelength I mean the sorry the bandwidth are in gigahertz. um, terahertz I mean sorry Plasmonic nano antennas we are using in biological and chemical sensing, optical imaging, energy harvesting, spectroscopy, increasing the energy of solar cells, near infrared application, optical clocking, and optical computing. These are references which we have taken from PO papers, but we have studied comparatively more. We have studied more papers which are not mentioned in these references, but are more okay. If you have any question about these presentations and concepts, you can you can write on my page. Okay, thank you so much.